Yeah, maybe we should just start there.
Sure.
Cool. All right. So hopefully everybody can see me. My name is Jeff. I'm the organizer of the Alaska Developers Alliance. I was going down to a conference in October last year in Miami, and I met Anjana on the plane. And it turns out that she works for Mapbox, and I told her a little bit about the Developers Alliance. We pinged back and forth on Twitter and via email, and I was able to convince her and her company to let her come up to Alaska. So yeah, she made it here. I'm super excited. There's a couple of notable things. I'm gonna probably re-give this full introduction again for the 645 one, but this is our first person to come from out of state, specifically to speak to the Dev Alliance. So that's kind of a huge milestone. I'm really excited about that.
I'm so honored. I'm so excited to be here.
Yeah, and also I'm really excited that it's Mapbox, which is a pretty cool company. So when I did some surveys out into the group and asked if there were people who were interested, there was a ton of feedback. I think some people might just be stuck at work, so I wouldn't be surprised if we have more people straggling in as the time goes, but thanks for being here.
Yeah, no, thank you so much for having me. I'm really excited to be here, meet all of you, and I was really excited to hear that folks have used Mapbox or heard of Mapbox. So what I was hoping to do today is just kind of go over a little bit of an overview of the Mapbox ecosystem and the things that we provide and some of the cool things that folks have built with our tools. I'm sure you all have really awesome things that you've built or you've seen built that I would love to hear about afterwards too, so we can also make sure to have some time for that. I would love for this to be like a two-way conversation as well. I don't want to just spew information at you, but I have some slides here so I can show you some examples and also go over a little bit of like how our maps work under the hood and how we kind of allow people to customize that, and happy to go into anything in more detail. If folks have questions, we can, I don't know if we typically do them at the end, or I'm happy to also take them whenever.
Casual.
Great, but yes, thank you so much for having me. I'm so great to be up here. I'm like so excited that this worked out. So yeah, I am Anjana Vakil. Hi. I'm easy to find because I'm the only Anjana at Mapbox and in most things. Yeah, you can find me on Twitter too at Anjana Vakil. So I'm a software engineer on our web-based renderer, so that our tool for displaying maps and basically an SDK for including maps in your JavaScript web applications, the client side. Hi. Which I'll tell you a little bit more about later. I've also spent time at Mapbox working on our engineering culture, especially learning and development. I used to be a teacher. I'm really passionate about developer education, and like teaching and learning to me go hand in hand. So I'm always looking to learn new things. I'm definitely a learner and not an expert when it comes to all of this stuff. Especially I haven't been in the geospatial world very long, so I'm sure some of you know much more about it than me, and I'm really looking forward to learning from all of you as well. So yeah, I'm also happy to talk about, if anybody has questions about Mapbox, the company, we are always hiring, of course, so yeah, happy to talk about that as well. But in any case, Mapbox, for those who haven't heard of it, or just as kind of a reminder, or refresher, basically we provide a location data platform based on live changing data that is intended to empower developers and designers and builders generally to build whatever location related experiences they need to do what they're trying to do in the world. So since location is definitely, the pun is sort of intended everywhere, the ways that people are using location data in applications, whether that be on mobile, on the web, in devices, embedded devices, in video games, whatever it is, location is really kind of becoming a integral part of many of these applications. And so what we're trying to do is provide the tools for people to build the custom location experiences that they need and want. And so what we do is we try to provide a platform that allows you not only to create beautiful customized maps, but also do anything else related to geodata that you might need, such as search and geocoding. So referring, basically making a mapping between places in the world and longitude, latitude coordinates, and going back and forth in whatever way you need to. Also navigation, getting from point A to point B, exploring huge spaces of possible navigation routes, things like that. And so we want to provide this platform to help people do all of these things kind of around the pillars of maps, search, and navigation on whatever platforms are most relevant for them and their users. So that could be mobile, that could be web, that could be things like Qt for in-car devices, for example. It could be things like Unity for game development or 3D applications. And so we have a variety of tools to make that possible. We kind of think of those as like Lego building blocks. We don't provide kind of a pre-built, ooh, we lost the video feed. I don't know if y'all can see it still in the Zoom. I'm not sure what oh, it's back. We kind of provide the individual blocks from which you can build the Death Star or whatever it is, hopefully not that nefarious, that you want to see. My friends are really into Star Wars Legos, so that's what I immediately think of. And the idea is that we provide those as a series of SDKs for individual platforms. So we have them for the two major mobile platforms. We have them for Unity and Qt, and of course JS on the web, as I mentioned. And in addition to those SDKs that make it easy to include our kind of client side a little bit more prepackaged, ready to go solutions, we also give you access to server side APIs that power those SDKs under the hood, even on our side. And so you can really get that fine-grained access to our data, fine-grained access to data that you've uploaded to us that we can then serve out to your users. Things like directions, things like geocoding, being able to access different map styles so you can have different views for your map for the different use cases you might have. All of that, we provide this huge suite of these building blocks so that you can put them together in whatever way makes most sense for you and your users. So many of you use Mapbox, I hear, which is cool. So maybe this is already something we can open up. I'd love to hear who's using it and for what. But just to give you an overview of some of our users and some of the things that they build with our tools, we have users and customers across a huge array of industries, verticals, of locations. We have customers globally. We have folks working in everything from agriculture to social networking, everything from like micro mobility and logistics and stuff to government data analysis and business intelligence. So really spanning a huge gamut of different use cases. And so just to go over some of the things that folks have built with our tools. One area that we've seen a lot of folks find a real value in Mapbox is, the slides will be back eventually, hopefully, is in business intelligence and data visualization. So you have some data that you're trying to understand to figure out, perhaps it's how your facilities are doing across your various campuses or areas of service. Or perhaps it's something more like an NGO. Sorry. I don't know what's going on here with our, oh, there it goes. Perhaps it's an NGO trying to understand geopolitical conflicts, or one of our earliest maps was mapping out voter fraud in the first elections in Afghanistan after the occupation, things like that. Or maybe it's something about business intelligence, analyzing your competition in the different markets you're in, et cetera, et cetera. So with platforms like Tableau or Watson Analytics, these are some of our clients that expose our mapping tools to people through their business intelligence platforms, so folks can take their data, see it in a way that they can then make most use out of. We also see that type of data visualization be very powerful and useful. What is happening? Okay. Sorry about these slides, folks. The connectivity is always a fun time. We also see that type of data visualization be really powerful in the field of storytelling and journalism. So, for example, the New York Times has used our maps to help people understand election results, help people understand trends in their states or in other regions, even on a fine-grained county by county level. and really making interactive tools so that it's no longer you're just reading a newspaper article. It's you can actually go on the New York Times website, explore the data yourself, manipulate it, look at it in different views, drill into the areas that are of most interest to you. So it really becomes a much more interactive way of doing journalism. We're going to try switching to HDMI here. And hopefully folks dialing in are not seeing any of these woes, except maybe you can see on my camera here how the screen keeps flickering in and out. Let's see what happens if we do this.
It's good and consistent.
Sorry?
It's good and consistent on the stream.
I think the broadcast system.
The broadcast seems okay. It's just in the room that we're having issues. Let's see if how Ubuntu feels about this. Oh, did that just burn everything? Oh. Sorry, folks. Meanwhile, you can all ponder the 2017 election results in Virginia.
I had noticed that they had mapping had gotten far more interactive at the time, so I was wondering.
Is this still the stream?
This should still be what I'm just showing to you all locally, but hopefully the stream is still seeing the slides okay.
Is that actually HDMI now, or is that still the Google Aircast?
That's a great question.
Nothing flickered, right?
You have to change your info on the TV.
Yeah, it might be. I think it's still the Google.
That's a little blurry. Just only have the bandwidth.
Sorry, folks. In any case, yes. So basically being able to make that data visualization not just, okay, we've crunched a bunch of numbers and we've come out with a static image, but making it truly an interactive application where people can explore it to internalize the information in whatever way makes most sense for them. So, okay, now I just need to adjust all my display settings. Bear with us, please. Oh,
Yeah,
this is,
that. So
sorry, I'm now advancing through the slides. Spoilers, sorry. Something has gotten messed up with Zoom here. I've lost,
There we go.
well, okay, let's not count our chickens till they've hatched here.
4K.
Okay, mirroring, hopefully getting there. Great, okay. Sorry, folks. Close this out, present here.
There we go.
And we're back. Okay, fabulous. So that's essentially when you have data that's numbers related to various locations in the world. You might also have data that is actual images. So in this case, satellite and imagery data is also something that we have tools and pipelines to help folks process, include on maps, and include into their mapping application. So for example, in California, when there were some really bad wildfires in Santa Rosa a year or two back, a developer named Robin Kraft, he took there was really, really great high quality, high resolution, up-to-date, super quickly available imagery released from, I believe, Digital Globe that was able to show the destruction where the fires had affected. But that data set was so huge that essentially you needed really, really strong GIS skills and really powerful software to be able to process it and make sense of it. So what this developer, Robin Kraft, was able to do was take some of our data pipelining tools and take that raw imagery, put it into a lightweight, easily viewable web map, use some of our UI features to compare different maps, to give people a tool, and also integrate our search functionality to allow people to search for their addresses, search for addresses of loved ones, and really understand on a house by house, neighborhood by neighborhood basis what the fires had done to their communities. In this case, what you're seeing, the red here is, I believe, vegetation, and the gray is kind of destruction from the fires. So this is we've seen this type of storytelling happen even in very kind of real time, with not just stats and figures, but also that visual from raw imagery data that we can expose through our tools. So another way that folks have used Mapbox to let me see if I can minimize this here, to tell stories is using crowdsourced or social data. So does anybody use Snapchat? SnapMap? A couple people. I don't know how to see everyone on the screen, but if folks have used Snapchat, they might be familiar with maps like these. So Snapchat has created a map using Mapbox tools to visualize your social network, what people are snapping, is that the word, about in different places around the world, whether they're your friends who you might see in their Bitmojis, or whether it's people you might not know. And this is cute and fun for holidays. They're able to use our highly customizable map styles to create these really fun and customized topical map styles like you might see for Halloween here. But this is also a really powerful tool for that kind of interactive storytelling where we're actually getting real-time information about, for example, the effects of hurricane and flooding in Houston, so that people could actually see in real time which neighborhoods were flooding, what stories people were able to tell on their own using their smartphones. Being able to visualize that in real time on a map like this, so Snapchat used Mapbox to do all this because it's highly performant, it's highly customizable, it's something that's able to serve maps to millions and hundreds of millions of people. And so this is another way that we've seen this used to take crowdsourced data or social data and present that in a really interactive way. And of course, that brings us up to the idea of these kind of mobile apps and ways that maps and location data can be useful when you're on the go. And so micromobility is a huge area where we've seen a lot of users take our tools and show where all of their bike share locations are, or the little electric scooters, or whatever the next electric pogo stick thing is going to be, etc. They have created these nice, useful mobile apps where folks can easily see, what their options are for getting to work, for taking a scooter, taking a bike, etc. So micromobility is another area that we've seen a lot of users gravitate towards us in. And as you might imagine, it's not just about like, how do I get from my house to work? It's also for companies that have to deal with logistics and figuring out things like fleet management, things like how do I make sure that all my drivers are able to deliver our packages in the most efficient way, given the current traffic conditions, given the current weather conditions, whatever it may be. We have a series of APIs that allow companies to very quickly compute, lots of different options for navigation and figure out the routes that make most sense for them, and then have that display on an app that the driver is using, etc. So in the space of navigation and logistics, we also have a lot of tools that are geared towards making that use case really, making it very easy to customize your experience around that use case. And the navigation thing gets really interesting when you start bringing it into the field of augmented reality. So there are this is kind of an experimental visualization of navigation overlaid on top of your handheld, whether it's smartphone or tablets, live video feed, live camera feed. We can actually integrate our navigation services and other things to give people this really immersive experience of as they're walking around a town, or as they're walking around an office building. Some of my colleagues built a prototype of an indoor navigation system for when you just can't remember where that conference room is. And so this is kind of like, now we're getting to the cutting edge stuff that people are starting to experiment with our tools in, and we're really excited to see where that goes. We're especially excited about getting that live camera feed from personal devices, so much so that we've created something called the Vision SDK that allows you to basically do live computer vision from a smartphone, such that we're using deep learning, we're using really impressive, I think, kind of deep learning techniques to build very powerful, but also very efficient and small systems to read in the live camera feed as, let's say you're driving down the freeway, and segment what it sees into different cars on the road, different street signs, warn you about the speed limit, warn you about upcoming construction, warn you about a bicyclist who you might want to brake. So we've created this SDK that allows people to build apps using this type of mobile computer vision, which we're really excited to see where people take this going forward. We just released that recently, so this is really exciting, fresh stuff for us. So these are some of the ways that folks have been using our tools. Obviously, it goes beyond just maps, as you've seen. It sort of goes into all kinds of different applications of location data, as I mentioned before. But the map is, of course, still a very core component of that. So what I'd like to do now is just sort of walk you through kind of how our maps are put together, what the different components are, the different layers, how we allow people to bring their own data in and really customize the look and feel of the map. So I'll maybe dive into that right now, but I do want to pause and see if there's any questions or comments or concerns at this point. Maybe a good moment. No? Has anybody else used Mapbox for any interesting use cases that I didn't just mention or touch on?
I don't know if you brought it up before, but I've used Mapbox in some during VR projects.
Yeah.
To be able to put like Revit models in the context of the city that they're located in.
Very cool. Yeah. We're working on kind of we have some. There's been some work to integrate things like your custom 3D models and even 3D point data from like LiDAR and things like that into our maps, and we're working on elaborating that more and really exploring the more dimensions that a map can take than the typical 2 that we're used to, or 2.5, and we tilt it back and forth. That's really cool. We'll look to see that later. Yeah, nice.
As far as the data in Mapbox and filtering that in an efficient manner, it seems like this is predicated upon giving the entirety of the data set to Mapbox servers.
That's a great question. So you can upload your data and we will serve it out for you, but plenty of people would either rather not, or for legal reasons or for concerns of privacy, don't want to hand over their data to our third-party servers, right? We're the third party in that case. We completely understand, and for that reason have also a solution for allowing you to basically use our technology on your side to serve up your data without it ever entering our hands. So you can use a lot of the tooling that we've built to do this on premise, for especially we have governmental clients or clients with really sensitive security concerns who prefer to or need to keep control over 100% of their data and never hand it over to other servers. And we have a product that lets you do that, essentially lets you use our infrastructure for your own data.
That's definitely interesting to me. Didn't interrupt you, right?
No, yeah, go ahead.
Because I can think of cases of data sets that I work for an ISP here in the state, and we have data sets that we'd love to be able to put in the hands of our mobile technicians. We don't necessarily want to host an app for them, but we can't necessarily, give our data away. We can't upload it to Amazon. We have a lot of data of that type that really does have to be hosted here in the state. So when I think about how do I assemble something for them, I like the idea of maybe not having to host the entire app here, certainly maybe not having to host the entire logic here, but being able to maintain a certain separation there.
Right. We also have some tooling that, let's say you just want some of the data itself to be hosted on your own API that you're comfortable running out. We have some tools to help you run a server that will serve the same type of map data that we would be serving from our side, but then you can still use our APIs and everything on our side that's just kind of for the number crunching and for the for getting the routing and whatnot, that doesn't actually see the content of your data. So definitely happy to talk about any of that in more detail if folks are interested. Yeah, perhaps we can take that offline after. Yeah. But in any case, yes, we totally understand this data can be incredibly sensitive. And so we've also spent a lot of time thinking about, how privacy and and control factors into our products. That's something that's really near and dear to our hearts and important to us. I'll talk a little bit more about that in a moment with some of the data that we actually use to enhance our maps and make them better. But yeah, it's great point. Yeah. Cool, so maybe that's a great segue. Thanks for, it's almost like I planted you there, into kind of what goes into a map. How do we do this? How do we serve up these custom experiences and allow people to build whatever their imagination comes up with? So essentially, we can think of it as having a map having 3 core components, at least the way we think of them. The one hand is the data itself, which we usually break down into what we call tile sets. So this is essentially a view of the world where the world is broken up into little square chunks, and your data gets processed into these little square chunks so that then we can serve it up and we can access it on the fly so that as somebody is zooming in and zooming out, they get the right chunks of data. So there's that data, and we're going to talk in a moment more about where that comes from and how you can use your custom data, etc. But so one way or another, you get your data ready to go, and then we have some kind of styling rules around how you want that data to be displayed, which data should be displayed, and in what ways, and with what response to user interaction. Talk a little bit more about how that works and the specification that we use to define styles. And then we take that data and we take those styling rules and we kind of put them into like the ingredients that go into our oven here. We bake it up into a map that you can actually see and touch and feel. And that's using a system for display or rendering, which we have different map renderers for our various platforms, like for our native clients and for our web clients. I, for example, work on this Mapbox GLJS is the name of our web map renderer. And so those renderers, what they do is they take the data, they take the styles, and they display it in the way that makes sense given what you specified. So we'll walk through these in a little bit more detail now, and just keeping an eye on time. Feel free to cut me off when we get short here. So looking first at the data, as we were just talking about, you know, there's geospatial data we want to be coming from lots of different places. Sometimes you have a little bit of data you want to put on a base map that gives you a general sense of what's in the world, the cities and towns. And so that's what we provide. We have our own map data. And so where do we get that? Well, our project is really, really tight with the OpenStreetMap community. I don't know if anyone has used OpenStreetMap or has heard of it. Lots of nodding in the room here. I don't know about on the stream. I can't see you all. Oh, great. Which this one is? Oh, it's so tiny.
I guess that was broadcast.
In any case, if folks haven't heard of OpenStreetMap, it's essentially Wikipedia for maps. It's an open source, community-driven project where people can go in and edit the maps. They can add details, map their own communities essentially, or map other communities from, let's say, satellite data. And so it's this community-driven open data project, very much akin to Wikipedia, if you think of that as a kind of another version of that. And so our project, or our maps are kind of at their heart based on OpenStreetMap data. You'll see, when you see a Mapbox map, you'll see a little copyright Mapbox, copyright OpenStreetMap in the bottom often. And we really love the OSM community. We contribute our changes back to the map so that we can, it's kind of a two-way flow of information there, so we can help make the OSM map better. And we are very involved in the community, in its gatherings, in its humanitarian projects, things like that. So a large part of where our base maps come from is OpenStreetMap. And then we supplement that with additional data. Some of it is open data from other data sets, like, for example, Wikidata or open addresses, which is kind of giving us more fine-grained data about, like, all the postal blocks, let's say, the postal addresses on a block. Also with imagery data, we mentioned earlier that satellite imagery, we have some data from the Open Imagery Network and various other open data sets. We also have some, we supplement that with some proprietary data. For example, our imagery, our satellite layer, I just think Anchorage looks so cool from the sky. And those of y'all in Fairbanks and Juneau can go onto our satellite map and take your own beautiful screenshots. In any case, that data comes from a combination of open data sources and also proprietary data that we've purchased, where we need higher quality, or we get our hands on some really great data sets, and we process all of that into a single map. In this case, an imagery, a raster image-based map of aerial views. And so we're able to take all those different data sources, both open and proprietary, and combine them into a single map. And we further augment that with telemetry data that we get back from users, customers of ours who've allowed their users to opt in to send back telemetry data that is completely anonymized, completely broken up in a way that we have no possibility of ever tracing it back to, like, that we could trace a single person as they drive around town, let's say, but we get an aggregation view of where people are moving, how traffic is flowing on a particular highway, or perhaps that there's a road closure because nobody is moving through that road. And so we're able to take that aggregated, aggregated, completely anonymized telemetry data from mobile devices and use that to make our map better, and then also contribute that back to things like OpenStreetMap to make those maps better. So we've used this to, for example, discover roads that we didn't know were there because they weren't on the map, but we see people moving on them, or vice versa, indicate road closures. It gives us also really accurate data about traffic and how people are moving through various corridors. That allows us to give people really accurate ETAs for navigation. So yeah, so that telemetry data is another important component of where we get our base map from. And the nice thing about telemetry is that as more people use the product, as we get more developers building, whether it be like hobbyists building their cool projects, or huge companies like Snap or the Weather Channel using our tools, they get that in front of more people. So we have hundreds of millions of end users touching our maps. Their telemetry data, if they've opted in, and again, aggregated, anonymized, gets fed back into our product, which makes the product better, which allows it to touch more people, which improves the map. So it's like this nice virtuous cycle of continuous improvement. And so what this all leaves us with, all of these different data sources leave us with this kind of pancake, I guess you could think, or lasagna, of different data layers that make up our map. Everything from that satellite imagery that we saw before to road networks, to the individual address points on those roads, to that real-time traffic data, and even things like 3D buildings. If we have building data sets that show us, where those footprints are and how tall the buildings are, etc. So we've got this kind of stack of layers here. And the nice part about our platform is that we allow you to take the parts that are relevant for you, leave the others. It doesn't come all smushed together into a single map. So you're able to really use the layers of data that make most sense to you and insert your data right in the middle of that, and however makes sense. So some of the other maps out there, they basically give you a map and they say, yeah, you can drop some pins on top of it, or you can kind of layer your data on top. But what we've really tried to do is give you as much flexibility and as much customizability as possible, so that you can take out the layers that don't matter. You can add in your own layers with your own data, whether that's hosted on our side or hosted on yours, and really make exactly the map that you need. So coming back to that question of, like, how do we deal with that custom data? The typical solution, the easiest thing for many users, is to create data sets that are then uploaded to Mapbox, and that Mapbox can then serve out. And so this could either be a data set that you upload that you maybe have in some other format that you've got from some other source, which then we process into our Mapbox tile set format. Or it can also be a data set that you create by hand even, or on the fly as you go. And that is all done through, we have this web interface to upload tile sets, work with them, share them, delete them, whatever you need to do. And so you can go onto our Mapbox site with your account, and you can upload a tile set that you have in let's say, GeoJSON format, or maybe you have shape files, upload that, it gets into Mapbox tiles, and then you can use that in your maps that we'll look at in a moment, how you style that data. You can also go in our data set editor, and even like if by hand, if you wanted to create your own features, create your own data by clicking on the map, as it were. It's a little bit more tedious, but sometimes the best way to go. And so we tried to make it as flexible as possible to work with whatever data you have or want to have. And as I said, we also have solutions to create that data, or to, if you already have that data that you want to be serving from your own side that we don't ever see or touch, that you can then just link to in one of your maps. So that's kind of the data side of things. Since we don't have infinity time, I'll maybe move on now to like how do we style that data? How do you customize the design of a map?
Just so you do know where we're at for time, the next meetup doesn't start till 6:45. So we
okay, great. So we want to make sure we have plenty of time for conversation and discussions. But great, I think we're generally on schedule then. In any case, before we dig into like how we display this, does anyone have questions or anything they'd like to bring up right now about the data side of things before we move on to the styling and the display? Hopefully it's answered a couple of the preliminary questions we had. And as I said, we can talk in more detail about some of the other, for example, the offline mapping solution or the on-premise mapping solutions.
This is a brief one about the tiles. So you make a tile set. How difficult is it to have tile sets that are three-dimensional? That is, that they have time as long as dimensions.
That is a great question. So this would be something that I think would depend on kind of how you're planning to visualize that data. For example, if that, we've seen things like, for example, a snap map, where you have snaps coming in every day, it's changing on the fly. We could be thinking about ingesting that data in many different ways. It could be that you're like creating a new tile set, you're processing these tile sets, whether it's daily or weekly or whatever granularity makes sense. Could also be that this is actually for a smaller data set, probably wouldn't work for the scale of Snap, but this is a JSON file that's being changed on the fly by the client, like even on the client side, if it's something personal or something that's living on the client. So there's really a large array of different options that we have for how to store that data and how to update it in a way that would make sense for the given data size, granularity, frequency of updates. Right. But essentially, and you could also consider that you could have a single tile set that where features, let's say cities, get an increasingly long list of kind of metadata about at this time the temperature was this, or at that time the temperature was that. I think there's many different ways you could break it down that would kind of depend on your use case, what would be most efficient, what would be most palatable in terms of the processing work needed, etc. Yeah, if you have something specific in mind, I'd love to talk about it later and see what we could figure out. Yeah. Cool. So, okay, so then once we've got our data, whatever it may be, whether it's Mapbox's data or your data or some combination of the above, how do we display that? How do we design a map that looks exactly how we want it to and that reacts to the user in the way that we want? So one core component of that are these styling rules that I mentioned earlier. Basically, rules about the data that you want to display and how you want to display it. And we have this nice kind of separation here now of the data in the map and the way the map is visualized. So it's no longer that the map is just a photo of a map or a raster image. It's actually, because we use that vector data, because we might be dealing with this raw data and displaying it on the fly, we can choose completely, it's completely up to us how we choose to display that. So we can create all of these different styles, we call them, for a given map. So here you're just seeing a rotation of some of our fun and designer developed styles, which we have a really nice collection of. We have what we call some of our base styles, which are things like you might be more used to seeing. We have things like Mapbox streaks, which just shows these bright orange highways and things like that. We also have some that are intended for things like data visualization, so like a dark monochromatic map so that you can visualize your data in bright fluorescent colors to make it stand out, what have you. We have those satellite maps, like I mentioned earlier. We have maps with traffic or terrain data built in. And then we also have some kind of more fun, funky maps that are designer styles. We have a series of those that you can work with, and you can take these and customize them, or you can start from scratch and build your own completely custom map style so that you can really have like totally different looking maps from the same data. So these are some more of our, we have some brilliant cartographers and map designers at Mapbox that have made some of these very cool maps that work for different use cases, right? Some, you might imagine that sometimes it's for a, you want something very much like on brand with your particular colors and your icons and things like that. You might want something that focuses on cities. You might want something that focuses on streets or highways. You might want something that doesn't care about streets whatsoever, but really cares about the terrain and really highlights that in the map design. So our goal is to make it as easy and flexible as possible to design literally whatever map you could imagine. And to do that, we have a really cool, well, I think it's a really cool web-based app called Mapbox Studio that's kind of like Photoshop for maps. It's essentially a graphical UI that allows you to go in and select the different layers that you want to see, change their colors, change their sizes, their relative positioning, et cetera, and all of this in this user interface that makes it hopefully the best combination of easy to use and also really powerful and flexible. And what is going on under the hood when you go in and you edit your map in this Studio Style Editor is it is under the hood creating basically a giant JSON document with specifying how all of the different types of data in your map should be displayed. That might be based on the type of layer that they are, like perhaps it's a layer of the road network and you want it to display in these colors. Perhaps it's a layer of the parks and waterways on the map, and what colors should that use? And of course not just colors, but you know, size, opacity, fading in, fading out, what zoom levels you want things to display at. All of that stuff is essentially captured in this JSON document, which conforms to a specification called the Mapbox Style Specification, which you can use not just in Mapbox tools, but also there are other tools like open source products that also allow you to use styles defined according to this specification in their solutions as well. So this is an open specification here. And I'm not going to go into too much detail about like all of the various possibilities because there's a lot. But essentially, the style spec is broken down into two, or a style that conforms to the style spec is broken down into two main parts. One is that you define what sources your map will be reading from. So this is essentially what data you're including in the map, where it lives. This is where you could point it to our servers, you could point it to your servers, and what type of data it is. So is it raster images, for example? Is it satellite imagery or other imagery that you're trying to display? Is it vector data? Is it maybe a GeoJSON of different features, again, stored in like a JSON document? You can even include video data, images, things like that. And then, so once you've got those sources defined, you would then also define the complement to that would be which layers you want to display on the map. And this is essentially saying, okay, from that data, those sources that I specified, this is which data to display and how. And that allows you to define your map in terms of different layers, which can take different types of shapes. So you can have layers that are more oriented towards filling in regions on the map. So let's say you wanted to show for example, some of the voter maps that we looked at earlier. You wanted to color in different counties, blue or red. You can also have layers that are lines like roads or walkways or waterways or what have you. Symbols are essentially like icons or labels like text labels. You can have raster imagery. For example, the Weather Channel uses that to do its Doppler maps. where you have an image of like, this is what the storm system looks like, and we're gonna put that over the map and update that very quickly. You can have circles for data visualization. You can have fill extrusion layers, so which allow you to get these cool 3D buildings or 3D whatever you want. Heat maps, and then terrain, hill shading that allows you to sort of visualize those hills and valleys. So we give you all of these options for what type of layers you want to display, and then you get to specify exactly how each of those layers is going to look, what order they're going to be in, how many there will be, etc. So this is a really high level and very fast overview of like how a Mapbox style works, but essentially it's you specify the data you want to display and the layers you want to display it in. And you also have the possibility to not just say, okay, all of the cities are going to have a circle that's this size and it's always going to be red. You can actually use features of the data to do what we call data-driven styling. So you can create these expressions. We basically have kind of a domain-specific language in here. It's like a little lispy, like special Mapbox language that allows you to define rules for how the map should change based on features of the data or features of the user interactivity, like for example, the zoom, where like how zoomed in and how zoomed out a user is might determine how you want to display certain things. You might want to, let's say here, in this example, you might want to change the color of a county based on its population, which is a feature embedded in the data. So you can use that data to actually say, if it's above 50,000, I want it to be this color. If it's above 500,000, I want it to be this color. If it's above 10 million, I want it to be the mother color, etc. So it really gives you like huge power over how the user experiences your map and what it looks like, what it feels like. And you can do all of this through this graphical user interface we provide through Mapbox Studio. You can also edit these documents by hand if you so chose, or use other style editors that might be out there. As long as they conform to this specification, we'll be able to take those styling rules and display the map you want to see. Which brings us to the next part, which is how do we display that map? How do we view it? How do we interact with it in our end user applications? So before we move on to that like display element, I don't know if folks have questions or anything they'd like to discuss about the style element, how we style these maps, the style specification. I've thrown a lot of details at you. So this is all also documented on Mapbox, a wonderful documentation site that our docs team maintains. So if any of that was that you'd like to go back and drill in more detail, it's all available, of course. But if anybody has questions.
Yeah, so this one's definitely kind of random, but what about like animation support for if you wanted to like drop a pin on a map for effect?
Yeah, so this is where you probably want to do that on the rendering side. So that's kind of the next element of what we get into is these SDKs that essentially expose the maps, which are defined by the data and the styles that you've created, and allow you to build in much more like customized interactivity, just as if you were designing a mobile app or a web app generally. So sort of integrating that map data with your app on the client side to allow people to, let's say, update the map data on the fly, drag a polygon around on the map, or create different effects as they hover over things like that, animations, yeah. So again, it's almost like I planted that question there because that's a great segue into our next topic, yeah.
Did that work on the JS libraries as well? Cool.
Yes, yeah, and we try to have as much parity as possible between our different clients so that you can have users having a similar experience on the web as they are on mobile, etc. There's some slight differences in what's available in terms of interactivity and whatnot, but generally our JavaScript client is the one that gets features first, and then they trickle into the mobile SDKs after that. So yeah, which I'll be happy to talk about in a moment. Yeah.
I guess I got a question about the difference between putting something into a tile and like bringing your own GeoJSON.
Mm-hmm.
When you do bring your own GeoJSON, I guess do you lose any ability to access all those GeoJSON features when it's built into a tile? Like, do you capture all of that data?
I want to say yes, we capture whatever data you tell us to capture, essentially, and you can choose when you're uploading it. You can choose, whether we want to keep everything or drop certain things for performance or what have you. There are certain subtle differences between tiles and GeoJSON. For example, when we create a tile set, we have to take all of the features, all of the information for this particular square of the map and put it into a single tile, a single unit. There might be something that spans a border of those tiles. So then we might have, for example, in the tile set, you might have duplication where that feature belongs in 2 different tiles now because it's needed in both. Whereas in the GeoJSON, you just have one. So there's subtle differences like that. And then there's also sometimes performance differences. For example, the processing that we need to go through to create the tile set might not be worth it if you have a very small data set that we can just load on the fly through the JSON. But if it's a really huge data set, you might have performance problems if you try to access it as GeoJSON because our tile sets are really optimized for that. There's kind of high density, large data sets. So there's trade-offs. They are not identical, but essentially the same information will be available. It's more a question of performance, storage sizes, accessibility, things like that. So yeah, if you have a particular case in mind, perhaps we can talk about it more later. And yeah, see if there's a clear answer. Great question though. Cool. Okay. So
Sorry, related to the data thing. So JSON was popular. I think it still is, where you can decrease the resolution of a feature or polygon. If the polygon had like 1 billion points on it, maybe a couple hundred of those are relevant to the visualization. Is there some way to control that in Mapbox if you have like a complicated data set, but you can tweak it to say like, okay, maybe there's really 1 billion points in the back end, but the client only needs.
Yes, that's something that probably, for that type of use case, we probably want to go through our tiling service, which then would allow you to, as you're creating a tile set from your, if it's GeoJSON or Mapbox features, would allow you to choose like, okay, I want this resolution at these zoom levels. I want this. I want to keep all of these features at these zoom levels, but once I get to forget it. I believe that if you're thinking about those questions of like, I have too much going on for it to be displayed at all zoom levels, you probably want to go through the tiling service so that you can have fine-grained control over the density and the kind of I want to say weight of this data at different levels. Yeah, and we have a few different tools to help you do that processing. Some of which, again, you don't necessarily have to touch or have to send it to our servers. You can use. We have a lot of open source tools that you can just use on your side to process the data into tile sets, and that's probably what you need to do if you're kind of concerned with that level of detail. Yeah.
GDAL.
Sorry?
Is it use GDAL?
GDAL?
GDAL.
GDAL. I'm not sure.
It's like GIS data abstraction layer.
Yeah. I am not entirely sure the exact relation or lack thereof between that and our tools. That would be a question I would love to refer to one of my teammates who works more on the tiling level and not on the rendering level that I work on.
Can I ask you a business question?
Sure.
So, and if you're going to get into this, definitely stop me. But so I saw your pricing up to 25,000 users is in the free tier, but that's a little foreign to me in terms of like how to sort of make sense of that. I was just working on a project that we were using Google Maps, and it was by a number of API calls.
Mm-hmm.
And that was a big surprise to us in terms of what we ended up paying out at the end of the month. Mainly, it's lots and lots of calls in terms of user distance from point and things like that. So I'm just kind of curious how you guys handle that.
Yeah, no, good question. It's different for our different products. So, for example, as I mentioned at the beginning, we offer you access to our APIs, and for those, it is often based on like number of calls, number of perhaps the volume of data that you're trying to upload or download, what have you. In terms of viewing the map, in terms of like end users looking at the map, that's where it's more based on individual sessions of like map viewing. So we recently changed this where we're no longer looking at it as we used to think about like, okay, how many tiles are you looking at right now, and how many tiles are you loading, and as you zoom in and out, that changes and might be more than you expect or even less than you expect, or it might be surprising in some way. So we've now tried to make it simpler so that it's more like when a user opens the map and loads the map on their client, they explore it as they will, and that's kind of one map view, let's say. I hope I'm not using the wrong terms, but we've changed it recently and I get a little confused in my mind. But in any case, yeah, if there are, we have like a calculator, a couple of calculators I think on the site that help you hopefully understand, okay, if I have this many users or I'm making this many calls, like this is what my rough estimate would be for how our billing would work. And we also just have an amazing support team who's totally great at working with people on an individual or working with companies on an individual level to figure out like what their bill would look like, how to optimize it. For example, perhaps there's a way, perhaps there's efficiency to be gained in using our tools a slightly different way or making slightly different API calls. So
we're not asking you how far Toronto is every 5 seconds or something.
But I guess it depends on the use case. It depends also on what the type of application is that you're building. But that's where again, like our really amazing support team is great at working with people to make sure that they're only making the calls that they need, that they're only loading the maps and the tiles that they need, things like that. Yeah.
I was working with Mapbox in the last company, and they just started out without the oil and then zoomed in, but we had to pay for tiles every zoom level. Not a very
Interesting, bro.
That's
Not a very smart design.
That's one of these like this surprising thing, right? So this is what we're trying to.
Yeah, because I was going to ask you about the tiles, because that.
Right, and that's where we've now moved away from these. I believe that I think I've used the word view before, but that's map view where like a certain set of tiles into these map sessions, right? So a little bit more kind of intuitive of what you'd expect, yeah. But it's certainly something that the industry is still working on figuring out the best solution for that makes things as predictable and as kind of straightforward and fair as possible. And so that's what we've tried to do with our recent pricing revamp. Yeah, but if you have more detailed or like specific questions about specific apps and things, I'd be more than happy to refer you to our the folks on our side of the team who'd be able to best drill down and help out with that. Yeah. Cool. Okay. So just to get back a little bit into the nitty-gritty of how the map is displayed to the users, and to go back to Jeff's question of how do we do things like animation and more sort of sophisticated interactions, things like that. That's where this like display element comes in. And so once we've got our data, we've got our rules for how we want that data to be styled, then we can put that all together in the client's lived experience of the map using our SDKs for mobile, for web, JavaScript, and also other platforms like I mentioned, Unity, for example. In this case, I'll focus on kind of the JavaScript and mobile side of things. So one thing to note is that unlike if you think back in the day to like MapQuest and things like that, where the map was essentially just a series of images and you could zoom out and you could zoom in, but you couldn't do anything in the middle. With the vector data that we've been talking about, where your data is stored in these tile sets, what that allows us to do is to really fluidly move around, zoom in and out, and really get a much more immersive kind of interactive experience with the map. And that allows you, or the fact that we're taking this vector data and we're essentially rendering it or displaying it into an image on the fly 60 times a second, just like a game engine or something like that would, allows you a lot more flexibility with how the map is displayed. You don't have to necessarily compute beforehand what the map is going to look like. You can do it on the fly. And that opens the door to all kinds of really cool animations, interactive effects, etc. And so as I mentioned, it's sort of like a video game. Like we actually use video game type technology to power our map renderers. The OpenGL project is the Open Graphics Language, I believe it stands for, is a project to allow us to render these maps. Well, it's for rendering anything really, but to render this vector data in real time on the client. We use OpenGL for our mobile clients, our iOS and Android SDKs, and then there is a web version, WebGL, very creatively named, that we use to power our JavaScript map renderer. And so what we do is we take the tiles that you have, the JSON document, the style specification that follows the style specification, and then perhaps other things like maybe you have your own icons that you want to be using on the map. And we use our Mapbox GL libraries, or there's a couple different libraries, to take all of that and display the map that you need for those particular 16 milliseconds, whatever it is. So what this enables is that we can completely redraw the map essentially on every frame. So as the user moves around, we can change the way, not only the perspective that they're looking at, but also, you know, the granularity of data displayed. We can animate it also, which I'll show you some examples of later. And so this gives us a much more kind of fluid and customized map experience where you can really get in there and play with the data as you need to. So on the JavaScript side of things, for example, what this ends up feeling like is you get this SDK that essentially gives you a map object, which then you can mess with as you see fit. You can tell it when to, how to respond to certain events that the map will fire when a user, let's say, zooms in or moves the mouse or what have you, just like you would with regular user interaction on your non-mapping web application or mobile or what have you. This is from the JavaScript one, but the principle is the same for the others. And that also means that you can essentially put whatever custom code you want into the app that's using this map. So you can be doing your own computations on the fly as the user moves around the map. You can be adding in custom layers that we haven't even thought of. So, you know, we saw those, we give you some examples like the heat maps and the polygon fills and things like that, but you can even write your own custom layers as long as they work with WebGL or OpenGL in the mobile case. You can integrate those. You can animate things. You can fade in and out different sources. You can have the images appear in certain places, but not others, things like that. So it really gives you kind of the world is your oyster type of control over what happens in the map. And we have a ton of really great examples on our website that show the sort of tutorials of how to go through and do different animations, etc. So what this means is that a map can be so much more than like just kind of a visualization of some points and some lines. So for example, we can have maps that integrate search, as we saw earlier. This is one where someone built a map to show whether or not your parking will be overridden by snowplow activity in Chicago in the winter, so you can like search for your address and really get in there and see like real time, like what's the parking situation.
That's the signal. Yes.
Yeah. Great. This is one. I'm going to try to load this. See if this will work in any of your tab. Let's see if the Wi-Fi feels like cooperating here. This is one that I think is pretty cool. It's like kind of an interactive story that visualizes ships as they move around San Francisco Bay in this case, but essentially showing the shipping lanes. You can see the big white. Well, hopefully folks on the live stream can see the resolution enough to see these little container ship symbols. And what you can do is actually create kind of like an interactive story where you're paging through and getting different views on the map, seeing different activity here. So this is, you know, all of this is kind of custom animation that's based on a data set of shipping activity and waterway traffic here. So that's one example. I've lost my other tab now. Let's see if this is right. Yeah. This is another cool one. This is a visualization of an eco-marathon run on Catalina Island in California, where you can, this is basically showing as someone runs through the race, and you can, it plays back in real time. Let's see if I can load this demo here. If we start the race here, it is drawing these 3D lines that show you the altitude at any given point on the race. And it's doing that as like sort of mimicking the progress this runner has made on this marathon. So it's another example of kind of doing this custom animation. You can pause, you can rewind, fast forward, etc. You can change the view angle. Here now we've lost the cool 3D-ness. Oh, it's back. Okay, great.
Is this how Sunto does that when you like follow a run after? Have you seen this?
Great question. Not sure, but in principle, it can be.
What is the metric they're using for height? It looks like it's just declining.
It looks like I think it's perhaps based on just the elevation at that point on the road, which might be coming from. It might
exaggerating the elevation data.
Yeah, and just showing that. Speculating here. It might be based on our terrain data for the island. It might be based on something else. It might be, I don't know, your heart rate as you run through the race or something like that. You could conceive of it being drawing from different data sets.
So I'm just curious, that's probably Mapbox.
I wouldn't want to say without actually knowing, but if it's Strava, I think it is Strava, yeah, they're that is pretty much it for my presentation. Is it now frozen on that one? Cool, great. So we can all ponder Catalina.
It's good. We're sort of back for a minute. We had another laptop down.
Sorry. Thank you. In any case, luckily that was pretty much the end of my slides there. Essentially, this giving you the map as kind of an object you can work with and program around opens up that door to possibilities for conceiving of things that we might not even have imagined, but that you can hack our tools together to build. And that's what we've seen. A lot of people build really cool visualizations using Mapbox, using especially our renderers like GLJS for the web. And what really excites us as like people who build this platform is to see what people come up with given these Lego blocks that we put together. And so yeah, it's that's what we really kind of live for, is like seeing these cool maps that people make, and people have made some very cool maps, which a lot more than this you can see on our website or link through, or like we tweet out some cool maps that people have made on our Twitter account, et cetera, et cetera. So yeah, when I get the slides back, I would point you towards our like demos and tutorials and examples on our site. They give you also more of a sense of some of the different things you can do in terms of animating lines, animating 3D things. There's another cool example I would like to show you about like you can use the input from the microphone to change how the map is displayed, things like that. It makes it really fun and kind of really allows us to think about maps as more than just these kind of static things that one provider shows us what the colors should be, and now we're all used to seeing yellow roads and things like that. No names being used, of course, but we hope that it makes it much more enjoyable, interesting, and useful to be able to create location experiences that go beyond just a simple map. So yeah, that's essentially what I wanted to talk to you all about today. I'll hopefully get another demo or two in if I can get this password typed in correctly. But in the meantime, while I'm restarting here, does anybody have any questions or any cool things that they've built that they want to show off? That would be awesome. Anybody? I hope we've been leaving enough time for folks dialing in to unmute and speak up if they have questions.
So I can also check the live stream and see if anybody is on that.
Great, and I'm gonna keep trying to type correctly.
I'm a little curious, I'm so sorry if I'm late, but I'm really curious about acquisition of data. You know, what our team used inside of Unity was, I believe, your extrusion data sets for like buildings and things like that. That comes up a lot in architectural projects.
Mhm.
Be able to simply convey context of like who's going to be casting a shadow on your property and things like that. But obviously, like there's no Mapbox, you know, street view cars that are cruising around gathering data. So,
Nope.
Are you guys building partnerships, you know, to sort of gather data beyond? Certainly, the world extends beyond Google and.
Definitely. Yes, and that's where, for example, a lot of our imagery data and things like that is based on our partnerships with imagery providers. 3D data and kind of like a better sense of buildings and the terrain and things like that. We have some, but we're sort of building on that, and no pun intended. And that's something that we're thinking about a lot. But like absolutely, we have a whole team that works on data partnerships and data processing, and we also, you know, we focus a lot, or we've spent a lot of time and energy investing in the tooling around this data. So that's where also we don't necessarily like try to hoard your data for ourselves. You might have your own data set that you're processing, that you're using our tools for, just in terms of the infrastructure and the tooling to get that data in there. And sometimes that gets contributed back to our map. Sometimes it stays in the hands of those who have it. So yeah.
And one of my biggest frustrations in dealing with Google Maps API has been the difficulty in integrating data that even is publicly available. So like USGS, Topo, and marine charts, you know, are not very easy to kind of integrate in with that system. And so it's not, I mean, we're definitely looking for providers whose APIs play nice with other kind of tiling systems like USGS and NOAA develop for their own maps.
Yeah, I can't speak to those particular data sets really, but again, you know, we have I'm not the exact right person to be speaking to our current kind of upcoming and ongoing data partnerships and things that we have in the works, but I'd be more than happy to connect you with the folks who would know in more detail about exactly where things stand and what types of things we're thinking about doing in the future, and what especially if you have particular use case or particular data sets in mind, be more than happy to connect you there. Yeah, sorry, I can't speak to it in more detail. It's all I can do to restart a browser. Sorry, we've got it going locally for folks dialing in at home, but trying to get Zoom back up, which may or may not be remembered in my browser history here. Let me see if I am still logged into this. Okay, everyone's gonna read my email. Here we go. Okay, great. Let's see if this works. Oh, I probably need to open this phone.
Like, it's okay, Zoom will install a web server.
Yes. It will bypass the sandbox, no worries.
Exactly, it's like, no.
Oh, hi, I joined the call. Let's see if this works.
You need to mute that laptop.
This one, okay. Okay, the sound, the output is muted. I don't know if the input is muted, but maybe if I do the output in here.
You got the owl, yeah.
Let's see, owl, great. Okay, I don't know if folks can hear, I don't actually even know how to.
Still have to unmute yourself.
Is this working? I don't know how to even ask you all. I can't see anybody in the live
You're
stream.
still presenting, that's the problem. Okay. So if you share, you should be good. Hit your share button.
Oh, yeah.
There you go.
Let's try this. Well, that is the wrong presentation. In any case, okay, we're getting there eventually. All right, the colors changed, but I just have one more slide to show y'all. And that is really just to point you towards some of these. Oh yeah, here's my cool. This is my favorite one. And now maybe if the microphone is working, this will work. Let's see. It's thinking about it. So this is a cool little example, just a fun demo. Go away, Zoom, okay. So if I allow this to use my microphone, I should see the buildings respond to the level of the audio input. So it's a really silly example. But if you make some noise,
Yeah.
we can see the city grow and shrink. Ooh, okay, cool. So anyway, this is all just to show that like you can really sort of think outside the box, huh?
Or raise the roof.
In terms of like what goes into a map, like we can integrate this with other. In this case, we're using the Web Audio API to access the microphone and use that as like map data in a sense. And so really, like the possibilities are limitless. And so the last thing I would show you, and pardon the color change here, but the docs.mapbox.com site has some really great examples, really fun ideas, I think of them as kind of like ideas to get your creative juices flowing, as it were. And of course, full documentation of how all of the different style spec options you have, the options that our SDKs provide, all of the things that you can do, and ways that you can get in touch with the team if you're having issues, if you want to, make sure that your data is optimized for how to display it at different zoom levels, or make sure that your API calls are not over the top and are going to result in a completely unexpected bill or what have you. So these are, I would send you all to the mapbox.com website and all of the documentation, examples, and support information there. If you haven't worked with it already. And if you don't have a Mapbox account, you can get one for free and just play around with it, which is like, that's what we really live for. Like I said, it's really to see what cool stuff people build. Everything from like individual hobbyists making just like fun maps to then that turning into a map that touches hundreds of millions of people every day. That's our game. So that's Mapbox in a pretty long nutshell. And of course, if folks have other questions, I'm happy to chat. I think we have some time.
Yeah. Any other follow-ups? We have pizza and beverages coming for the next.
Awesome.
Cool.
We can map out like where the
Yes,
pizza burner is.
We have 23 minutes. Go. How good is that API?
So I would jump down a bit of a rabbit hole here because it was stuff you kind of touched on right as I walked in, but I'm a VR developer, so I've been working in Unity for a few years.
Very cool.
A few projects. But, indoor mapping seems to be what's next. It really is like the biggest frustration of consumers is that once they get a view of the sky, like they're relying on GPS, like, whoa, why can't this get me to where I want to go? Is there active development going on in the company? Or are you looking to partner with folks?
So we've thought quite a bit about the indoor mapping problem. It's sort of a it's not quite a solved problem like industry-wide or economy-wide yet. I think there's a really interesting article on our blog about some indoor mapping prototypes. I showed a really brief screenshot earlier of like a little prototype app that some of my teammates had made with Unity for indoor navigation. And that goes, sorry?
Are you using Bluetooth beacon? Or are you using some other?
It's a great question. We can go look it up in the blog post. But essentially, exploring some of those different options, using Bluetooth, using Wi-Fi signals, using a combination of the above.
There's a lot of privacy implications to having it be bidirectional, whereas GPS is one way.
Right, and also reliability implications, and the problem of needing to have special hardware, special beacons set up throughout your space. So, and then we're also looking, you know, for example, the Vision SDK that I briefly showed earlier, which allows us to do, to basically take your camera feed and segment it into geographically relevant units on the fly. That might also have some interesting implications for what we could do indoor-wise just based on the visual signal. But all of that is kind of in the experimental, like thinking it through stages as far as I'm aware. I am not exactly sure what our current status report is on how we're thinking about indoor and how actively we're thinking about indoor, but.
Yeah, I guess I wonder from a business standpoint, are you trying to simply facilitate those applications, or does Mapbox have an interest in acquiring indoor data, for example, partnering with folks, you know, as we begin to see infrared cameras and depth cameras show up on hardware, to be able to actually say, like, yeah, we have the inside of that shopping center and the data belongs to us, you know, under US law, so, you know, Mapbox can be able to acquire its own data sources for indoor stuff, or is that totally out of the wheelhouse where you're going, it's just kind of implemented?
It's definitely not totally out of the wheelhouse. Whether it's, we're still a pretty small company. We're 400 and I want to say 50-ish right now, and so we have to very much, you know, we have to be very pragmatic about what we work on when, and so I'm not sure exactly how many resources we're dedicating to that right now, but it's certainly something that is, you know, on our radar. You know, again, all these different ones are coming on our LiDAR. Yeah. And we've seen some of our customers, some of our partners have used Mapbox tools to across their own. Perhaps they have really detailed schematics of their buildings, their campuses, things like that. But to my knowledge, we haven't talked concretely recently about focusing on that space. It's certainly something we'd love to see more growth in, and we'd love to, you know, help out with as much as possible. But I think there are some other things that we're thinking about a little bit more urgently, let's say.
So then like stepping back from that, are you partnered to begin to kind of ingest people's raster maps? I mean, if, for example, like, you know, DPW at like Burning Man 2020 is like, here's going to be the map of how we're laying stuff out. Like, oh great, like we'll go ahead and put this in here for you. Or is it more of a question of like, yeah, if Burning Man wants to be a client and go ahead and integrate that as the app, then they would pull their own data down and pull down like our
street map
at the same time.
It's something. It's so when we've worked with customers who are actually like they go out and build solutions for other people. So there's sort of like another degree of separation there. So we have, to my knowledge, we have a couple of customers that are more focused or more specialized in, let's say, the kind of like campus mapping or facilities mapping, things that might border on indoor, but where they might be using Mapbox tools to build their platform that then is more tailored to that use case. So that's what we're still a pretty general purpose location data platform. And since we're still a pretty small company, we've got, limited resources, we found that like a lot of those kind of partnerships, users of ours who are also empowering other users in certain areas has been a powerful tool to kind of help the whole community do more things better. If you have particular questions about like individual, data sets or use cases or whatnot, again, I'd love to follow up maybe offline after the talks about that. Yeah. Did you have a question or thought?
Sort of related. Do you know anything about the future of Mapbox GL that you're excited about, or we should look out for?
Sure. Well, so one thing that's exciting is on the mobile side. So we use, as I mentioned, OpenGL. It's been kind of at the heart of our map renderers. But now on Apple, they're moving towards their own rendering or graphics framework, Metal. I almost called it Metallica, which that would be really funny. And so we've ported our renderer to Metal. We have somebody's been working really hard on that, and it's exciting to see it, work with different graphics platforms. So who knows what the future could hold there. Also, in terms of the not just indoor things like the 3D, how the building is structured and whatnot, but also how we're thinking about terrain data, for example, or getting more of a three-dimensional map to take shape. It's really hard to avoid these times. Yeah, I'm not even trying. Is something that's like on our minds right now. Is what could that look like? Now we have the possibility to do building extrusion and things like that, but we would love to see more power in that sort of 3D space, and also thinking about, again, with the Vision SDK coming out, that's really new and fresh, and so we're like, it's all tons of ideas around how that can feed back into our maps and then really become a core part of our mapping experience. So yeah, lots of exciting stuff. We're also, we want to make sure that the map is as globally useful as possible. So some of the things, like personally, I've been working on making sure that we support other languages, other scripts, other ways of thinking about text, or even conventions for cartography and things like that in different locales, and making sure that our map has the flexibility needed for other users in other markets than those that use Latin left to right, horizontally written scripts, things like that. So yeah, and the Mapbox GL.js project, just like Mapbox, its counterpart is called Mapbox GL Native, which powers our native SDKs. Those are open source projects on GitHub. We totally welcome and encourage external contributors, whether it's coming in and filing a bug report, or coming in and grabbing a good first issue and like helping us out with some stuff that we don't have the time or developer power to work on. It's all there out in the open, so you can see some of the issues that are out, some of the things that people are working on, the pull requests that have been submitted that aren't in the released version yet, but will be coming down the pike in the next months. All that stuff is right there on our GitHub. So, and like tons of other things. We have a lot of open source tooling, some of it map related, some of it more general purpose. So yeah, the Mapbox GitHub org is a fun place to hang out if you like that sort of thing. And yeah, contributions always welcome. And input also, even just a thumbs up on an issue can be a really valuable contribution. So yeah. Yeah.
Cool.
Can I just ask one naive question? So there's raster tilesets and vector tilesets, and vector tilesets are awesome in my experience. Raster tilesets are less awesome. Is it possible to vectorize raster tilesets in a good way, or do people not do that?
That's a good question. I think it depends on what the content of the raster tiles would be. For example, for satellite imagery or aerial imagery of some kind, it's not immediately clear how you could turn that into a vectorized.
Yeah, but
data
people
source?
will do like SVG previews of images before they load and stuff like that.
So if it's something that's more might lend itself to a vector representation better than an image representation or raster image representation, then I'm not sure that we have any particular roadmap for tooling to do that, to like make that inference for you. But I'm sure that there are ways to kind of hack through it if you were really determined.
Okay.
But I think what we focused on is making it easy to combine the two, making it easy to, let's say, overlay your raster images over a vectorized map so that you are only using the raster images at certain zoom levels or in certain situations when you need them, let's say, and not forcing you to choose one or the other. I don't know that we have a solution for magically transforming one into the other. Because, rasterizing a vector tileset is a lot easier, I suppose. We do have tools like to create a static map if you just need an image of a map on your website and you don't need to load a whole WebGL context that's immersive. If you just need like a, here's where our store is kind of static map, we had to get for that, but the other direction is a lot more complex. So I'm not too sure. Yeah. Yeah. Cool. Well, I want to make sure everybody has time for
Yeah, we should run
pizza and whatnot.